All right, let's go over our warm-up. The first problem on the warm-up for Wednesday is to find the slope of the line. So to find the slope of the line, we're going to find 2 points on the line. So because this is proportional, I have my point at 0, 0. And I'm going to simply follow the line until I have another place where it intersects between two numbers. So right here. I'm doing Thursday. Oh, there's Wednesday. Sorry about that. Okay, I'm like, no, I'm doing Wednesday. I just had the wrong one showing. Okay, so back to Wednesday. We're going to go up 1, and we're going to go over 3, because slope is rise over run. So our slope is rise is 1, run is 3, so our slope is 1/3. Okay, and our equation is y equals slope times x, so y equals 1/3 times x. Hopefully we're getting better with slope now that we're looking at it individually and not, and we're mixing it now with y-intercept. All right, let's look at the next one. We're graphing a line that has a y-intercept of 3. Y-intercept means it crosses the y. You see, this is the y. The y goes up and down. Crosses the y at 3. So that means I have a point at 0, 3, and I'm going to place my point at 0, 3. Okay, so that's 1 point. And then the problem gives me the second, -2, -4. So I'm just going to plot that point. -2, -4 is right here. And so I have 2 points, and all I need is 2 points to create a line. So I'm going to connect my points like so. All right, for the table, y-intercept. Y-intercept means I'm adding something. So since I'm adding something, I'm looking at what's happening from x to get y, from x to get y, from x to get y. So 0 to -3, it seems like I'm subtracting something, and I am, but subtracting 3, right? 0 minus 3 is -3, 1 minus 3 is -2, 2 minus 3 is -1. This is subtracting 3, so that means my y-intercept is actually a -3. So my y-intercept would be 0, -3. So when you have a table, if it's multiplicative, that's going to be your slope. But if it's additive, that's going to be your y-intercept. So the equation for that table, we know that the slope is 1, so it's just x. And then it's -3, our y-intercept. Okay? And then the last one, the equation. She paid, Mary owed $3 to her friend and paid her batch, it should be back, $1 per day. So is this proportional or additive? It's additive because we have two things happening. She has $3 already, and it's $1 per day. So she starts out by owing her friend how much? $3. Okay. So when she owes somebody $3, what is she starting at? Not 0. If I owe somebody $3, am I even at 0? What am I at? -3. So my y-intercept is equal to -3 because I owe her $3. So my equation for this would be y. It's $1 per day, right? 1x. And then I'm starting at -3. But I don't need the 1. I can rewrite this to y equals x minus 3. So that one was a little trickier, but you just need to think about it. If I owe somebody something, that's going to be a negative. To get back to, just 0, I have to add 3. So what we're going to do now is you guys are going to complete, Genesis, can you pass these out? You're going to be thinking about what we did yesterday with the diagonals. So we're looking at diagonals of quadrilaterals. So you guys, it's already kind of done for you. You can see that the diagonals are already drawn. What I want you to do is to redraw these shapes in the appropriate place on the Venn diagram. Okay, so here we have diagonals are perpendicular. Let's write some notes here. Perpendicular means form right angles. Okay, if they're congruent, what does congruent mean? Same what? Same size or same length. So you're looking for, over here, you're going to put the shapes that just form right angles but aren't congruent. Over here, you're going to put the ones that the diagonals are congruent but not necessarily form right angles. And then the shapes that do both go in here in the middle because they have that in common. And then down here, go ahead and write neither, because there are going to be maybe a shape or two that aren't going to fit anywhere. It doesn't have perpendicular or congruent, so you could put those shapes outside the Venn diagram. So I want you to be looking at them and figuring out which ones go where. So we're going to pause the video here and then we'll unpause once we've had a chance to finish. All right, let's go ahead and look at the shapes and see which ones go where. So we're going to start with the square. The square is going to go in the middle because the square has congruent. So these two lines are congruent, and they also form 90-degree angles. Okay, so the square goes in the middle. Okay, so now let's take a look at the rhombus. If you look at the rhombus up here, you can see that there's 90-degree angles formed. And are the diagonals congruent? Who's got my rhombus that I sent out? Okay, here's our rhombus. Okay, so look at the rhombus. Are the diagonals the same length? No, because you have one green and one what? One purple. You see how they're different. Okay, so the rhombus has two different diagonals, so they're not congruent, but are they perpendicular? Are they perpendicular? Do they form 90-degree angles? Okay, so we're going to say that the rhombus is going to be perpendicular. Okay, what about rectangle? Rectangle. Are the diagonals of the rectangle, look right here, are the diagonals of the rectangle congruent? Do they look like they're the same? Those lines? Yes, but do they form 90-degree angles? No, if you look at those angles, they're not 90-degree. So the rectangle is going to go, diagonals are congruent. Make sense? So you guys should be adjusting your shapes if you put them in the wrong place. Next we have the trapezoid. This is an isosceles trapezoid. And for the isosceles trapezoid, you can see that our diagonals are the same length, but do they form 90-degree angles? No, they don't form those 90-degree angles. So isosceles trapezoid is going to be congruent. Okay, and then our last two shapes, we have parallelogram and kite. Parallelogram, you can see here, let's take a look at the diagonals. One second. I'm going to get rid of this. Try to get rid of this. Let's just put it down there. All right, pause for a moment. Okay, so our parallelogram, If you look at the diagonals on the parallelogram, you can see this one here is shorter than this one. So the parallelogram is going to go down at the bottom. It doesn't even belong in the Venn diagram because it doesn't have perpendicular, nor does it have congruent diagonals. So it doesn't form 90-degree angles, and it doesn't have two congruent diagonals. So the last shape we're going to look at is the kite. You can see that the kite, this line here is longer than this line here. So this is not congruent, but is it perpendicular? Yes, it's perpendicular. It's not both. So now that we've looked at our diagonals, we can see the properties of the diagonals. We're also going to talk about bisecting. We didn't put that in the Venn diagram, but that's something else we can talk about as we go through our notes today.
All right, so now we're going to do some notes. I want you guys to go to this part of the handout where it says quadrilateral notes. I want us to go ahead and get all of the properties of the different shapes. So the first quadrilateral we're going to talk about is going to be trapezoid. Trapezoid is unlike any of the other shapes. A trapezoid has the following properties. It has 4 sides, it has 4 angles, and it has exactly 1 pair of parallel sides. We have different types of trapezoids. We have an isosceles trapezoid. So if we have an isosceles trapezoid like I'm drawing here, an isosceles trapezoid has, if we draw the diagonals, congruent diagonals. Okay, so that's what's true about the trapezoid. An isosceles, but look, a non-isosceles trapezoid, if we draw the diagonals, does not have congruent diagonals. So the only type that has congruent diagonals is the top one. So that's our first shape. So think about it.
Oh yeah, I am, but I don't have headphones on. So we're picking up with trapezoid. Just to reiterate what I just wrote down, a trapezoid has 4 sides, 4 angles, because it's a quadrilateral. It has exactly 1 pair of parallel sides. We show parallel sides with the arrows, like this. And then an isosceles trapezoid also has 1 pair of congruent sides, just 1. And then the second one is not an isosceles trapezoid, but it is a trapezoid because it has 1 pair of parallel sides. The diagonals, an isosceles has congruent diagonals. You could see those lines going across. They're the same length, but they're not perpendicular, just like we explored today in the diagonal activity. So that's our first shape of the quads. So now we're going to go to parallelogram. Okay, so a parallelogram has, just like a trapezoid, we can draw it first. A parallelogram looks like this. Okay, just like the trapezoid in all these shapes, it does have 4 sides and 4 angles. It has 2 pairs of parallel sides. Okay, so it has, these 2 sides are parallel, and then also these 2 sides are parallel. Okay, so 2 pairs of parallel sides. it also has two pairs of congruent sides. So to show the congruent sides, we use little marks like when we did similar figures earlier this year. I can use those little lines to show, those little dashes to show that those two lines are congruent. They're the same length. And then over here I'm going to use two lines to show that they're the same length. So I've got two pairs of congruent sides. And then the last thing we're going to look at are the diagonals. So the diagonals, and we can look at what we did before. The diagonals of a parallelogram are what? Look at your Venn diagram. What does it tell us about the diagonals of a parallelogram? Diagonals are not perpendicular. Are they congruent? Nor are they perpendicular. Okay, I'm going to give you a minute to catch up. So we've got two shapes so far. We have our trapezoid that has one pair of parallel sides. And we have our parallelogram that has two pairs of parallel sides, two pairs of congruent sides. And the diagonals, we put it outside the Venn diagram because the diagonals were not congruent, nor were they perpendicular. They were neither one. So now we're going to start talking about shapes that have different names. So the next shape is a parallelogram, but it's a special parallelogram. Does anybody know what shape I'm talking about that's a parallelogram but is a special parallelogram? Anybody know? Yes, a square is, but we're going to talk about this shape here. What shape is that? No, it's not a kite, it's a rhombus. This is a rhombus. So a rhombus is our next shape, is also a parallelogram. Rhombus is also a parallelogram. It has both names. The most specific name, put a star by it. It is, listen, this is going to help us not to write so many notes down. Because if you know a rhombus is a parallelogram, it has all of these characteristics. So we're just going to put same as parallelogram. Because it is a parallelogram, it has two pairs of parallel sides, it has two pairs of congruent sides. The diagonals are different though. We are going to talk about the diagonals being different. So it's kind of hard to draw. So that would be a rhombus. So it has two pairs of parallel sides. So I'm going to show that. There's my one pair of parallel sides. There's my two pairs of parallel sides. Okay. It has two pairs of congruent sides. Actually, it has even more than two pairs of congruent sides. It does have two pairs, but what's true about the sides of a rhombus? What's true about the sides? What do you guys notice about the rhombus? What's true about the side lengths? The side lengths are all the same, so we say they're what? Congruent. So what makes it special is side lengths are congruent. And we're going to show that the side lengths are congruent. We don't have to do two 1 dashes and two 2 dashes. We're going to make them all 1 dash to show that the side lengths are all congruent. They're all the same. That's what makes it a rhombus. It's a parallelogram where all the side lengths are congruent. And then just like we saw before with the diagonals, if we take them across, what was true about the diagonals of a rhombus? Were they the same length? Were they the same length? No. Is green and purple the same? No, but do they form 90-degree angles? Yes, so we're going to say side lengths perpendicular. Okay? So that's how it's different. So the way it's different from a parallelogram, side lengths are congruent and side lengths, oh, sorry, that's not side lengths. What should it be instead of side lengths? What's the word that I should have written? Not side lengths, but what? What's perpendicular? What are they called? You guys, what are those orange lines called? Diagonals. They're perpendicular. Okay? And notice that that's different from the parallelogram. It has the same as the parallelogram in that it has two pairs of parallel sides, two pairs of congruent sides, but their side lengths are all congruent. So the next shape is also a parallelogram and is a rhombus. This shape, actually let's go with is not a rhombus. This shape we're going to draw is a rectangle. Okay? A rectangle is also the same as a parallelogram. So let's look at it over here. It's the same as a parallelogram because it has two pairs of parallel sides. So this side is parallel to this side, just like a parallelogram. This side is parallel to this side, just like a parallelogram. But what else does a rectangle have that a parallelogram does not? Right angles. Good. So it has right angles. How many? Okay, so it has 4 right angles. That's what makes it special. Because it's just like a parallelogram, but it has 4 right angles. The last thing to note about a rectangle is our diagonals. And the diagonals are what? Are they perpendicular? No. Look at your paper, guys. Look at your Venn diagram. That's why we did that first. Is your rectangle in the section that has perpendicular diagonals? No. The diagonals are what? Congruent. Good. So the other names for rectangle, a rectangle is also a parallelogram. It's a special parallelogram, but it's a rectangle that is also a parallelogram. The most specific name for it is rectangle. Now our last shape, what's our last shape? We're not doing kite. What's our last shape besides the kite? Square. So we're going to draw a square. And then we're going to talk about it. Does a square have 2 pairs of parallel sides? Yes. So we're going to draw our parallel sides. Does our square have 2 pairs of congruent sides? This pair and this pair. In fact, a square also has side lengths congruent, right? All the sides are congruent. What other shape has all the sides congruent? What other shape has all sides congruent? What shape is this? A rhombus. What other special quality does the square have? It has our right angles, just like the what? Just like the rectangle. So we have the right angles. Okay, so this is what I'm going to write for my notes. It's a parallelogram. It's also a what? Rhombus. And it's also a rectangle because it has all of the same qualities as the rhombus and the rectangle and the parallelogram. So that's our square. So square is the most specific name, but again, it's also a parallelogram. It's also a rhombus because it has 4 congruent sides, and it's a parallelogram, and it's also a rectangle. So when you're asked to name these shapes, the most specific name is the one that you're going to see, the one that you know, but you also need to recognize that if it has all of the other characteristics of the other shapes, you need to include them. You need to recognize that it's also that type of shape. And that's it for our notes on quadrilaterals.